Yesterday we kind of introduced angles. We talked about angles. We talked about maybe some types of angles that we have. Today is some more with angles. And here, the angles that we're going to be looking at are going to be like pairs of angles. So it's going to be like two angles together, and what can we say about those two angles together? And there's a lot of different types of pairs that we're going to have. So the first one is what we call an adjacent angle. If I were to give you this big angle right here, and I were to draw a ray through the middle, then this angle and this angle would be adjacent. Okay? And I marked them differently because they're not necessarily congruent. Okay? In some cases they could be congruent, but they are adjacent. Bless you. They have this ray that goes right through the middle and kind of splits them, but these two are next to. That's what the word adjacent means, is next to. Okay? If I say my neighbor's house is adjacent to my house, it means it's right next to me, right? They have a common vertex, they share a vertex, and they share a side. So like on this one, we're talking about this angle here, we're talking about this angle here, they share this common side. So that would be what we call adjacent. Complementary. If I have a right angle that is split, these two angles together would make 90 degrees. Okay? Now, they don't necessarily have to be adjacent, though. They don't have to be touching. I could give you an angle here, and I could give you an angle here. If I tell you that this one is 40 degrees, and this one is 50 degrees, if I were to add these two angles together, I would get 90, and so we would say that these two angles are complementary. Complementary means 90 degrees. Okay, the next one is supplementary. Okay, supplementary is very similar. Here I have a line, and I'm splitting that line with some ray, okay? But how many degrees are there in a line? What did we say yesterday? A straight angle is 180, okay? And so if I split it, then these two could be like, this might be like 120, and this might be 60. But together, those two together make a straight line, which is 180 degrees. Once again, they don't necessarily have to be adjacent. I could give you two separate 90-degree angles. And if I put those together, they would make 180 degrees as well, okay? So as long as the two angles add up to be 180, whether they're touching or not, we can call those angles supplementary. Okay, we see this word linear a lot in different math classes that we do, okay? A linear equation, we did last year in Algebra 1 a lot, where we graphed a line. A linear means a line, okay? Well, in geometry, we deal a lot with lines again. So when we talk about a line here, okay, linear means line, pair means two, so it's a pair of angles that form a line. And once again, I could do a ray any direction from that line, and I would say these two angles together form that line. Because we still have a line, right? The line's still there, and then these two together would make that line or form that line. Okay, and then once again, it would be 180 degrees, because we know there's 180 degrees in the line. So not only would they be supplementary, but they would also be a linear pair, because they form a line. Okay, this one right here is a linear pair. This one is not, because they are not touching one another, right? They have to actually be touching, they actually have to form that line. Okay, the last one, this is one that we're going to see a lot as we go throughout the year in a lot of different scenarios. Okay, if I labeled these four angles, 3, 4, 5, and 6, okay? And that's just naming the angle. We have two pairs of vertical angles. The two lines form an X, right? And so when we have that, the angles that are directly across from one another are vertical. So 3 and 5 would be vertical. And I'm going to go ahead and tell you right now, vertical angles are always congruent. That's a piece of information that we will always use and know from here on out. Just something to kind of keep in your back pocket. Vertical angles are always congruent. So angles 3 and 5 are congruent. Angles 4 and 6 are congruent. Now, what if I asked you about 3 and 4? What do you suppose I would say about 3 and 4? What do they do? What would be true about 3 and 4? What do they make? A line, right? So we could say that 3 and 4 are a linear pair. 3 and 4 are supplementary, okay? And so just looking at that picture, we can kind of use some of those pairs that we just talked about and kind of put those together. And you're going to have some problems on your big ideas today that kind of talk about some of those things. Okay, going down here to this picture. DAC and DAB, DAC and DAB are two different angles, okay? And I'm talking about the common error here, okay? Even though they share a common vertex, they don't share a common side. So if I was going to name two adjacent angles here, I would have to go DAC and then I'd have to go CAB because they share side AC, right? AC is a ray that splits it. So a pair of adjacent angles, I would say angle DAC and angle CAB. Okay, would it be okay if I just called this angle here angle A? No, right? Because remember what we talked about yesterday? There are three angle A's here. There's this angle, and then there's the big angle A. There's three angle A's. So if I say angle A, I have no idea which angle A we're talking about. Okay, so that's why we got to use three letters. The only time on over this one over here, could I call this angle angle S? Yeah, because it's the only angle at angle S. Yeah, Hannah?
I still don't quite understand why BAC wouldn't be an adjacent angle.
It would. So
Oh,
BAC and CAB are the exact same angle.
Hold on.
So
I wasn't looking, so.
yeah, so you're exactly right. BAC. It just kind of depends on how we name it. Yeah.
Hold on.
But the one up here we were talking about was DAB because it didn't have that common shared side. Okay, a pair of complementary angles. So here what we're looking for is two angles that add up to be how much? 90 degrees, okay? So do these two add up to be 90? No, because we're already over 90. So really I can't even use 127, right? Because I'm already over 90. So I'm looking at two acute angles. What happens if I add 57 and 33, or 37? 53 and 37. You get 90, okay? So 53 plus 37 equals 90. So we're going to use those two, and we're going to say angle CAB and angle TSR. Those would be my two complementary angles. Okay. And there's more than one way to name those. Like this one over here, I told you that we could just call it angle S if we want to. I could call it RST, I could call it TSR. There's a lot of different ways that I can name it. Okay, supplementary, what do we need them to add up to be? 180, okay? So I need two angles that add up to be 180. So 127 plus 53 equals 180. So we need the 127 angle, which is angle CAB, and the 53 degree angle, which we could just call it angle S if we want, or RST or TSR. Lots of possibilities there. Oh, CAD, yes, sorry. CAD, thank you. Okay, this one's a little bit different picture, okay? Once again, it's asking the same three questions, but just a little bit different picture, so it's a little bit different identifying what we want. Okay, adjacent angles. Nothing has to be true about those two angles other than they share a side and they have a common vertex. Okay, so what would be a pair of adjacent angles here? What point would they have to share? G, right? So we would have to say FGK and angle HGK or KGH. As long as G's got to be in the middle. That's the important thing. The vertex must be in the middle, so G's got to be in the middle. Okay, complementary, we're looking for two angles that add up to be 90. So what two values can add up to be 90 here? Okay. So we would have to add the 41 plus the 49 to get 90. Okay, and so that would be angle FGK again. And LKG. Okay. And I'll keep saying it, but there's more than one way to name it. So if you say LKG and someone else says GKL, we're talking about the same thing, okay? And so order can be different on some of those angles. Big key is what's the one that's in the middle that we have to pay attention to. Okay, finally, what two numbers are going to add up to be 180? 131 and 49, okay? So we just got to, first of all, find two numbers that add up to be 180. And we're going to name the two angles that identify those two angles. So 131 would be angle HGK. And then 49-degree angle would be LKG. Okay, moving on to this next one. The word complement. Complement, good morning. What does complement look like that we've already talked about today? Thank you.
See ya.
See ya. What does complement look like that we've already done? Okay, there was a word we already talked about that kind of 90 degrees, right? Complement is a form of complementary, okay? I'm not saying, hey, you look nice today. That's a different kind of compliment, right? This is a complement of two angles that add up to be 90, okay? So if I tell you that one of those angles is 62, what's the other angle got to be? Yeah. Yeah, so how do we get that? 90 minus 62, yeah. Because complement means 90. So we know what the total needs to be, and we know one of the angles. So to find the other one, we just take 90 minus 62, and we figure out which one, what's it going to get to. And then that would be 28, okay? So we would say measure of angle 2 equals 28 degrees. Okay, when you see this label here, M usually means we are looking for an angle measure of angle 1 or a measure of angle 2. This is what we talked about the other day when we were naming angles as well. This angle 2 is used to name the angle. I know I don't have a picture here, but it's just used to name it. So we have an angle 1 and an angle 2. Okay, so it's just another way, instead of using letters, because we don't have any points here, we don't have a picture, we're just calling it angle 1 and angle 2. Okay, same thing here. The word supplement. Complement meant complementary. Supplement means supplementary. So it's two angles that are supplementary. One of them is 47. We got to find the other one. We know that supplementary means 180. Okay, so it's just a form of the same word, supplement, supplementary. And we're going to do 180 minus 47. And that would get us to 133 degrees. So angle 3 would have to be 133 degrees. Okay, we've got this ball return. One of those where you kick the soccer ball into it and it shoots it right back at you. And it kind of leans back and it forms an angle with the ground. Well, on one side, it forms an angle over here. On the other side, it forms kind of an obtuse angle. So we got an obtuse angle. We got an acute angle on the other side. Together, those two form what? 180 degrees, right? They are supplementary. And it tells me that right here. It tells me they are supplementary. They form a line, okay? If the ground is flat, it's going to form a straight line across. These two angles together are going to add up to make what? 180, okay? So we're going to do 5x plus 10 plus 3x plus 2. And you probably don't necessarily need the parentheses here, but I'm going to go ahead and put it in parentheses just to separate them and say this angle plus this angle has to add up to be 180 because they told us they were supplementary. We saw some problems like this yesterday, so now it's going to be a solving. And what would be our first step to approach this? Combine like terms, you bet. We got 5x, we got 3x. We're going to combine those together to get 8x. 10 plus 2 would be 12. And now we're just going to solve it out from there. Subtract 12 from both sides. And 168 divided by 8. What's that give us? Okay, 21. 28. Okay. Okay, so if x equals 21, so, and here's another thing we talked about yesterday, and we've talked about it quite a bit. If it says find x, sometimes the problem will say find x. If it does, we're done, guys, okay? But this one does not say find x. It says let's find the two angles. So now what do I got to do with 21? Got to plug it in, okay? So in order to do BCE, measure of angle BCE, we're going to do 5 times 21 plus 10. What's that give me? 5 times 21 plus 10. Okay, 115. Okay, and then we want to find the measure of angle ECD, which is 3x plus 2. So here we're going to go 3 times 21 plus 2. 65 degrees. And we kind of talked yesterday about checking our answer, right? Well, once again, today, we can check it because what we just said at the very beginning is these two angles, once we find out what they are, have to add up to be 180. Does 115 plus 65 equal 180? Sure enough, right? That gives us a little bit of good feeling when we get to the answer and, hey, sure enough, those add up to be 180, okay? So always look at that answer at the end and ask yourself, does this make sense, right? If they don't add up to be 180, then I got to figure out, I probably did something wrong somewhere along the line. Some of my math went wrong somewhere. Okay, this problem is very, very similar. Just got to pay attention to the keywords today. When I see the word complementary, complementary means what? 90. Okay, I'll give you guys this little hint. Sometimes people get complementary and supplementary confused. Okay, so think about it this way. C comes before S in the alphabet, right? And then 90 comes before 180 on a number line. So C comes before S, 90 comes before 180. Complementary goes with 90, supplementary goes with 180. Kind of a quick and easy way to think about it if you get those two confused. So kind of like we did on the last one, we're going to do 4x minus 2 plus 9x plus 1 equals 90. Just got to make sure we're using the right total. And once again, a lot of the solving is very similar here. We've got 13x Negative 2 plus 1 would be minus 1. Really watch your signs. Signs are going to be probably the thing that throw us off the most here. Add 1 to both sides. I'm probably going to get out of the habit of writing every step down because we've solved equations for a while now. But if there's ever a time when you're like, where in the heck did 91 come from? Just ask, okay? But I'm probably not going to write out every single step that we do, just for the sake of saving a little bit of time. And then 91 divided by 13 would be 7. Okay, and then it asks for the measure of the two angles. So the measure of angle LMN is 4 times 7 minus 2, which is 26 degrees. The measure of angle PQR, 9 times 7 plus 1. 64. Okay. And if I wanted to check it at the very end, these two should add up to be 90, and there we are. They do. Okay. The last page here, just lots of different types of angles here. I don't really feel like we need to do this one. We've already done one like this. I mean, actually a couple of them. This one is supplementary, so we would just add them up, set it equal to 180, and solve. So just really watch your keywords, your numbers, okay? Let's jump down here to this one. Linear pairs, okay? Linear pairs. Pairs means 2. So for instance, on this picture here, if I was asking you to name all the linear pairs, I can't do 1 plus 2 plus 3, because how many angles is that? It's 3, okay? It's not a pair. Pair means 2. So it can't be 3 angles, can't be 4 angles, has to be 2 angles that add up to be a straight line. Same thing is I can't do 2, 3, and 5. Okay, what would be one pair of a? Okay, 1 and 4 would be good. Okay, and we know that they're a linear pair because we have 2 that form a line. Here's my line. These 2 are right next to one another, so they form a linear pair. Okay? These 2 down here, right? 4 and 5 form a linear pair. Do we have any others in that picture that form a linear pair? Okay. So 1 and 3 are angles, but we would need to include 2 in there as well because these all 3 together. Okay. Same thing here. I think that'd be it. I think we just have those 2 pairs that form a line if we're only looking for 2. Okay, vertical angles. This one's a little bit tricky because we're looking for 2 angles that form an X and they're directly across from one another. Okay, so like 3 and 4 are across from one another, but it doesn't form an X, right? Because I would need to continue this ray on. It's not. So 1 and 5. 1 and 5 would be the only vertical angles in this picture. They must form an X, which means both lines have to continue on in both directions. You can't just draw a ray that stops. All right, these last 2 are a little bit different, kind of similar to the ones we did just a few minutes ago, except they don't give us an expression to start off with. Okay, so let's kind of go through our keywords that we've talked about today. Linear pair. Linear pair tells me what? It's a line. Okay, what do we know about a line? 180. Okay, so let's break it down into some small pieces here. We have 2 angles that need to make 180 degrees. One of the angles is 5 times the measure of the other angle. So this is a good old algebra kind of story problem. Okay, everybody's favorite, right? When we say story problems. We know we have 2 angles. So I'm going to say X is the first angle. You can use whatever letter you want. X is our kind of our go-to that we'll use most of the time. Okay, and what you could even say is sometimes people like to do it this way and they say X is the smaller angle too. Okay, however you want to do it. Okay, What would be an expression that would represent the second angle? What do we know about that second angle? It's 5 times bigger, right? So how could I write an expression that's 5 times bigger than the first one? And what would we do with the 5? Multiply. Yeah, just 5x. 5 times x. And this one is the larger of the two. Okay, because it's 5 times the small one. 5 times bigger. Hey, so those are my two expressions. They didn't give me those. We came up with those on our own. But now what would be true? What do we say about these two angles? They are a linear pair, right? And so those two angles together make 180. First angle plus second angle equals 180. If there's no number in front of the x, we know that's an assumed 1 right there. So this really becomes 6x equals 180. And then we divide by 6. Okay, so this angle over here is 30 degrees. How do we find the bigger angle? Multiply by 5. So 30 times 5 is 150. Okay, so two things are true here. Is this one 5 times bigger than this one? Yep, that's the first thing that has to be true. What else has to be true about these two? They have to add up to 180. Both things are true. So we've got it solved. Okay, so it's just kind of a little story problem with some words that we have to kind of set up a way to do it. Okay, identifying variables is really important. All right, let's try this next one. This time we see the word complement. Look for those key words in your problem right away. That would be 90, okay? If I see complement, I know 90. If I see supplement, I know 180. If I see linear pair, I know 180. Keywords are going to be really, really important on our problems today. Once again, we have two angles. So x is, let's call x the small angle. Okay, what do we know about the bigger angle? It's twice. So what would we do for an expression for the big angle? Multiply by 2, 2x. Okay, and then the definition of complement means two angles add together to equal 90. So we're going to do x plus 2x equals 90. So this would become 3x divided by 3. So my small angle would be 30. My big angle would be 60. Do these two together add up to be 90? There we go. Okay, everything looks good.